Alright, in this video we're going to look at what simultaneous equations are and how to solve them. Okay, simultaneous equations refers to when you've got two lines on a graph. So let's say here's one line that we've graphed and here's another line. Okay, they've got different equations and different intercepts. They're different equations, but they're both on the same graph. You can see that they cross over each other at this point here. Okay, at that point there they cross over. We can say that at that point that they're simultaneous. They're the same. They have the point at which they intersect would have the same coordinates. So there's a set of coordinates x and y at which these two lines intersect, and that the two lines are the same. That they're simultaneous. Okay, when we talk about solving simultaneous equations, what it means is we're trying to find what are these two coordinates, what are the x and y coordinates where these two lines intersect. Okay, so that's what we're going to work out how to do. How do we find out what the coordinates are of these this point where the lines intersect? Now there's three ways to solve a simultaneous equation, a set of simultaneous equations. Three ways to solve these sorts of problems. The first one is called the graphical method, and the graphical method means kind of like we've done here on this graph. We draw a graph, we draw the two lines, and we try and estimate based on what we know about the scales on the axes what the coordinates are. So if I had the scale on these axes and we had some numbers. So this is 1, 2, 3, and this is 1, 2, 3. Then I can make an estimation that the coordinates of that point, they're about, x is about 3, and the y is about 1. Okay, so I've just solved this equation using the graphical method. Okay, but obviously with the graphical method, the solution you get, it's going to depend on how accurate your graph is. I've just done this I've made a very rough graph here. I haven't measured out these points, and I kind of looked very quickly to see what the coordinates were. So that was a very rough solution to the graphical method. If we took some time, we could do it a lot more accurately. But there's always going to be a certain amount of guesswork in the graphical method. Okay, the second way is called the elimination method. And the third way is called the substitution method. Okay, we're going to look at the elimination and substitution methods and work out how to do those. Substitution method. Okay, let's talk about the elimination method. In order to solve two simultaneous equations, like these ones here, using the elimination method, as the name suggests, we've got to eliminate something. Okay, the way we eliminate something is we've got to arranging our equations in such a way that when we add them together, something's going to get eliminated. Now I've chosen two equations here that we're going to try and solve to find out where they intersect. I've chosen them because they happen to have this element here. Look at this, 3x in this equation, 3x plus 5 equals y. This has got 3x in it. And this other equation, it's a different equation, it's got negative 3x plus 9 equals y. So you can see that the 3x part here and the negative 3x part here, they're kind of opposite. Here's what will happen when we add them together. This is how we do the elimination method. We add the two equations together, which means we're going to add this side and this side together on one. That's going to form one side of our new equation when we add them together. And then we're going to add this side and this side together, and that's going to form the other side of our new equation. Okay, so if we add together 3x plus 5 and minus 3x plus 9, 3x plus minus 3x cancels out, and we've got 0 there. 5 plus 9 equals 14, so we've got 14. And over this side we've got y plus y, which equals 2y. Okay, so now we can rewrite this equation. I don't need to write this 0 here, that's pointless. So I'm just going to write 14 equals 2y. And now that we've eliminated the x's, we can solve for y. So we just divide by 2, and we get y equals 7. Okay, now that we've got y equals 7, we've got the y, this is the y coordinate for our graph, for where these two lines intersect. I don't know what these lines look like. I'm just going to say they look like this and this. And the point of intersection that we're looking for, we now know the y coordinate is 7 at that point. Okay, so in order to find the x coordinate, all we've got to do is substitute this value y equals 7 into either one of these equations that we started with, and we'll get the x value. Watch. Let's do the first one. 3x plus 5 equals y. Okay, so we've got y equals 7. So we'll change y to 7. We'll right here let y equals 7. So now y is 7. And over the other side we've got 3x plus 5. Alright, now we've got to solve for x. Minus 5 minus 5. 3x equals 7 minus 5 is 2, and then divide by 3, and we get x equals 2 over 3, x equals 2/3. So now we've got the x and the y coordinate. We've got x equals 2 over 3, and we've got y equals 7. So that is the point. That's the coordinates of the point where these two equations are going to intersect. So we've solved the equation. We've solved the simultaneous equation problem. Okay, and in order to check that our answer is correct, if we put these, if we go into the Casio ClassPad, I'll just show you how we got here. So go to Menu, Graph and Tabulation, and then in here we enter in what our equations are. So I've entered in y equals 3x plus 5, that was our first equation. I've also entered in y equals negative 3x plus 9, that was the second equation. This, the fact that it's got y1 and y2 here, don't be thrown by that. That's just because you can show several equations, so we have to differentiate each of the y's. And then once we've put in the equations here, then we just graph them by pressing this button up here. And we can move around our graph and we can zoom in a bit because I want to get a bit closer to this point. These are the two lines, obviously. The two lines are represented by these equations that are shown on the graph. And I'm trying to zoom in as much as I can on the point where they intersect. And if I click on it, then the coordinates are revealed just down below below the graph. So you can see the x coordinate is 0.714, which is pretty close to 2/3. 2/3 would be 0.66. So that's pretty close, and you can see that as I move the mouse just 1 point across, it changes fairly dramatically. So it's hard to get the exact right spot, but you can see that we're close. And the y value is 7.36, which again is very close to our answer of 7. Okay, so this is just a way of confirming that our solution is correct. These numbers, we can't expect by clicking that we're going to get on the exact right spot, because every little pixel on the screen represents a slightly different value, but the fact that we're so close is a very good sign that we got the right answer. Okay, now here's another elimination method problem. We've got two equations again. We want to find out where they intersect, and we're going to do the same thing that we did before. We're going to put these two equations together, but if we look at the two equations we're presented with this time, it's not going to be as easy as it was before, because if we add this equation to this equation, then the x's are not going to cancel out, and nor are the y's going to cancel out, and we need one of them to cancel out. So we're going to have to try something a little bit different this time. Okay, what we need to do is to adjust one or both of these equations so that when we do put them together, there is going to be a cancellation. Okay, and I'll show you how to do that. Okay, now let's make a decision now that we want to get rid of the x's. That's what we're going to try and eliminate. we're going to try and eliminate the x's. In order to get one set of x's to eliminate the other, they need to be the same and they need to be opposite. Okay, so what we need to find is the lowest common multiple for these numbers here, 2 and 3. The lowest common multiple is the number where they're going to match up, where they're going to be the same. And hopefully you can see that for 2 and 3, the lowest common multiple would be 6. Okay, so we're going to try and get this 2x to become 6x, and we're going to try and get this 3x to become 6x as well. Then they'll be the same size. Okay, how do we get 2x to become 6x? We multiply it by 3. Okay, now when we do something like this, it's okay to multiply things by a factor as long as we do it to everything. We've got to do it to the whole equation. And whatever we do to this equation, we don't have to do the same thing to this equation. So for this equation, to get 3x to become 6x, like we want it to be down there, we're going to have to multiply this equation by 2. Then that'll become 6x. But again, we've got to do it to the whole equation. Alright, when we do that, when we multiply this equation by 3, the 2x will become 6x, the 3y multiplied by 3 will become 9y, and the 4 multiplied by 3 will become 12. In the second equation, 2 times 3x will give us 6x, that's what we want. 2 times 2y will give us plus 4y, and 2 times 10 will give us 20. Okay, so now we've got two equations, and we've got the 6x bit is the same. That's what we need so that we can eliminate them. Another thing we're going to do differently with this equation, we don't have to add them together. We can subtract them. We can subtract this equation away from this equation. That just means we have to subtract everything in this equation from everything in this equation. So we can either add or subtract depending on what we want to do. It's up to us. Alright, here's how this is going to work. 6x minus 6x cancels out, so now we've got 0 there. 9y minus 4y equals 5y, and 12 minus 20 equals negative 8. So now we've got a new equation with no x's. We've eliminated the x's. That was the whole idea of the elimination method. We've eliminated the x's, we've just got the y, and we can solve it now. 5y equals negative 8. So divide by 5, y equals negative 8 over 5. So that's our y coordinate, and hopefully remember that to find the x coordinate, we need to put this y value into one of those equations. So we could use one of these new equations, or we could use the old ones. It doesn't matter, they're all the same in a way. So we'll use the old one, it's a bit simpler. We'll put y in as negative 8 over 5, so we've got 2x plus 3 times y is now negative 8 over 5. That's from this equation here, and it equals 4. Let's put that into a calculator. Alright, here we can see that when we multiply 3 by negative 8 over 5, we get negative 4.8. So in this equation now, I'm going to write 2x plus negative 4.8 equals 4. Okay, now positive and a negative like that just means it's a negative. And we want to solve this, so we'll go plus 4.8 on both sides. And that cancels out. Over there we've got 2x equals 8.8, and then divide both sides by 2, and we'll put it up here. X equals 8.8 over 2, which equals 4.4. So our final solution, the coordinates of the point of intersection are 4.4 and negative 8 over 5. Okay, now I've graphed these two equations again, the two equations we had at the start, and I've done it this time a different way. I've gone into the main window. The main window is where you do all your normal calculations, and I've just typed in the two equations there. You can see I've typed them in. Okay, and then I've clicked on the graph button up here. clicked on the graph button, and then dragged these two equations, highlight them, and then drag them into the graph box. And it's graphed them for me. And then I can see the point of intersection is down here, and I'm going to click on that point, and here's what I'm getting is the point of intersection. Down below, the coordinates are 4.5, which is very close to our 4.4 that we've got over here. That's our x coordinate. That wasn't supposed to happen. Okay, so we've got 4.4 as the x coordinate, very close to what the graph shows, and negative 1.6, which is almost exactly, I think it is actually exactly negative 8/5. Okay, so we've ended up with a very good confirmation that our solution was correct. So that's all you got to do. Go into the main window, type in your equations, and then click on the graph button that's up here, and then you can drag them into the graph, and it'll graph them for you. Okay, finally we're going to learn how to do the substitution method, which I think is the easiest method to solve simultaneous equations. To do the substitution method, we've got two equations again. We want to find out where they intersect, where they coincide, what that point is. We've got to have one of the two equations in terms of the rest of the equation. So in this equation here, we've got y equals 2x plus 3. We need one of the equations to look like that. It's either got to be y equals blah 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 or x equals blah blah blah. Or if we're using other letters, then it would have to be, the other letter equals something something. Okay, once we've got one of the equations like this, then we're ready to substitute it into the other one. Okay, so in this other equation, see how we've got y here? Okay, we're going to substitute y equals 2x plus 3 into there. Okay, because we know from this equation that y equals 2x plus 3, we're going to put 2x plus 3 in for y. That's what we're going to do. Substitution. Alright, so let's do that. Let's rewrite this equation, but instead of writing y, we're going to write this, because that's what y is. So we're going to write 4x minus, now y is 2, I'll put it in brackets, 2x plus 3, and all of that equals 5. Okay, now it was a good idea to put this in brackets, because this minus that's here, that I've got to put there, it's got to apply to the whole of y. Okay, and if I had have just written minus 2x plus 3, then we would think that the plus 3 that the 3 is actually a positive, when the 3 is going to get affected by this negative here. Okay, so putting it in brackets helps to avoid any confusion like that. So now we know we've got 4x, and we've got to do minus everything in this bracket, because that's what y was, it was everything in that bracket. So minus 2x and minus 3 equals 5. Okay, now we just have to solve for x. So 4x minus 2x is 2x, and minus 3 equals 5. Get rid of the 3 by doing plus 3 on both sides. 2x equals 8, and divide both sides by 2, x equals 4. Okay, so that's the x coordinate for where the points intersect. To find the y coordinate, we just have to substitute x into either one of these equations. Doesn't matter which one. We'll use the first one. It's kind of set up for it. So y equals 2 times x is 4 now, and plus 3. So that's 8 plus 3 is 11. So y equals 11 is the other coordinate. So our answer is 4 and 11. Don't ask me why I put that little curve there. That's a 4, and 11 is the answer. Okay, now I've written out the two equations in the calculator so we can check them. I'm going to drag them down, drop them in there. We can see the point of intersection is up here, so we're going to have to scroll up a bit. And here it is here. If we click on that point, we get 4.1 and 11.2. And the coordinates that we were expecting were 4 and 11. And we've got that almost exactly. We've got 4 and 11.2, very, very close. So I reckon we've done it right. Now, of course, with the substitution method, if you were given an equation, and it wasn't in this form, y equals 2x plus 3, you might have to rearrange it to make it y equals or x equals, so that you can then substitute it into the other one. So you may have to do another step in there to rearrange the equation if it's not already set up for you, and then you can substitute it in. Okay, I'll just mention quickly two particular situations that might arise when you're finding simultaneous equations, when you're solving simultaneous equations. One is parallel lines, and the other one is coincidental lines. Parallel lines, hopefully you're familiar with that term, is when you've got two lines that have the same gradient, the exact same gradient. Okay, so these two lines here, although they're in different places, they are rising at the exact same rate. They have the same slope. And two lines that are parallel, that have the same gradient like that, they're never going to touch. They're just going to continue on forever and ever and ever, and they're never going to meet. They're always going to stay the same distance apart. Okay, so for parallel lines, there's no solution, there's no point at which they're going to intersect. So trying to solve parallel lines, you won't get a solution. For coincidental lines, those are two lines that are right on top of each other. So if I had another line and I drew it over the top of this first one, okay, how many points of intersection are there? Well, there's going to be an infinite number. Okay, at every single point they're intersecting. Okay, so everything will be a solution, which is kind of no solution at all either, because we can't write down every single infinite number. So everything is a solution for coincidental lines. So in either of these two situations, you're not going to get a pair of coordinates where they intersect. So look out for both of those situations. Parallel lines, same gradient, that would be the clue for that one. They would have the same gradient. And coincidental lines, they would actually be the same equation. And you might think, well, that'll be obvious if I look at two equations and they're the same. But just think about this. Y equals 2x plus 3. I can rearrange that equation. I can make it look like something else. I can go minus 3, minus 3. And now it's y minus 3 equals 2x. Okay, those two equations, they're really the same equation. They look a bit different, but on a graph they're going to be exactly the same. They're going to be right on top of each other. So don't think you'll always know when you're looking at two equations that are exactly the same. These look a bit different, but they're actually exactly the same. Okay, and finally here's a summary of what we've covered in simultaneous equations that you can copy into your book in order to refer back to later. But like with anything, the best way to get to know simultaneous equations is to practice them. So make sure you do plenty of the exercises.